In these notes, we're going to be solving rational equations, and it's going to be a continuation of the last lesson, but this time we're going to have some binomials and trinomials in the denominator. So make sure you have your heading. What we always want to do is try to get rid of all the fractions first. So that is what my starting sentence is going to be. Try to get rid of, all of the fractions. In the last lesson, we learned that we could cross multiply if there were two ratios, two fractions equal to each other. We also learned that we can multiply everything by the LCD. That is what we're going to be focusing on today. So we're going to be doing the LCD again. So if you could write LCD. What we're going to do is multiply everything by the LCD. So could you write multiply every term, by the LCD. And that's your least common denominator. If you do that, it will cancel out all of your fractions. The one thing that you want to do though when you get an answer is to check for answers that will not work, which are called extraneous roots. So I'm going to put one more sentence here. Make sure to check for extraneous roots, extraneous roots. And what that means is you are looking for answers that will make a fraction undefined, where the denominator equals 0, or a radical won't work, or a square won't work. So I'm just going to put in parentheses here, undefined fractions, radicals, etc. And we'll be checking those in our calculator today. You're going to see that some of the answers won't work. So our directions, we're going to do two examples here. Before we get into it, I'm going to have one quick example. This is going to be example A. We're not going to solve this. Let me just share and unshare it really quick. Noticing my screen is frozen. You don't want that to happen. So I'll get the video back up. Okay, so hopefully it's sharing now. Oops, still not working. There we go. So let me share again. Sorry about the pause. Then we won't have to start the video over. Okay. So what I want to do is just have a question talking about undefined. So can you write why can't, I'm going to have you write an equation. So our first fraction is going to be x plus 1 over x plus 5. Next to that is a plus sign. Then another fraction, we're going to have 18 over x squared plus 8x plus 15. Then the end of the equation is equals, and our fraction after that would be 9 over x plus 3. So my question is, why can't this have roots, that means answers, have roots of x equals -5 or x equals -3? The reason why you could not have these answers if one of them happens to be an answer is that it would make the denominator undefined. So if we were to plug this in right here, we would have -5 plus 5. That would give us 0. If we plugged in this over here, -3 plus 3, that would give us 0. So that would give us undefined terms. So what we're going to write for our answer is they would make the fractions undefined. They would make the fractions undefined. So whenever we have an answer, we always want to check it to make sure we're not going to have a denominator of 0, because that will not work. So what we're going to do now is we're going to try to solve this equation. So I'm actually going to do it on a separate sheet just to make sure I have room. So I'm going to copy this example all over again. So let me switch. And my directions are going to be solve and check. And we're going to write that example all over again. So we've got two fractions that we're adding, and it's going to equal one other fraction. So there's my setup. So we have x plus 1 over x plus 5. Then we have 18 over x squared plus 8x plus 15. And at the end, it was 9 over x plus 3. What we're going to do is solve this. So just like in the previous notes, what we have to do is find the LCD. And in order to find that, we need to factor every single denominator, and then our LCD is going to be pretty much one of each. So over here, I cannot factor this, so I'm going to leave that. Here, I have a power of 2, so I'm going to try my 2 sets of parentheses. I can put x and x in the front. Factors of 15 that add up to 8 would be 5 and 3. And because I'm adding, I need the same sign in both pluses. So I'm going to change that old denominator to this. Over here, I can't factor that, so I'm going to leave it. My LCD is going to be one of every piece, and I don't want to repeat. So I'm just going to put right here, LCD equals. I need an x plus 5 because I see an x plus 5 in the denominator. Over here, I already have an x plus 5, so I won't add that again, but I see an x plus 3. So that's part of my LCD. Over here, I have x plus 3. We already have that. So this is the LCD. This is what we're going to multiply every single fraction by. So what I'm going to have you do is rewrite this original problem one more time, because we're going to put this next to every single fraction, and it's going to get a little messy. So I'm just spacing this out. So I have x plus 1 over x plus 5 over here. Then I'm going to put plus, write this again, 18 over x squared plus 8x plus 15. And then I'll bring this down. I'm trying to leave room next to it so I can multiply by my LCD. You want to see the original problem. So if we do this right, we're going to multiply every fraction by this over 1, and then hopefully our fractions cancel. So I'm going to put next to this x plus 5 times x plus 3, and I'm going to put it over 1 because I need to make it a fraction. Over here, same thing. I'm going to do x plus 5 times x plus 3 over 1. And the same thing over here. I'm going to multiply by x plus 5 times x plus 3 over 1. Take a second to write that down if you need to. So every fraction I multiply by the LCD. If we've done it correctly, our denominators will cancel. So if we start over here, I have an x plus 5 and an x plus 5 on the top and bottom, so I get to cancel them. I am left with an x plus 3 and also an x plus 1, and I'm going to put it in parentheses because I need to multiply that. So I have x plus 3 times x plus 1. Moving over here, remember that this was the same as x plus 5 times x plus 3. So if you want to rewrite it, you can. So that was what this was the same as. Notice we have an x plus 5 on the top, an x plus 5 on the bottom, so they cancel. We're just left with plus 18. So plus 18. Over here, we have an x plus 3 on the bottom, x plus 3 on the top, so I get to cancel those out. I am left with a 9 and an x plus 5, so I'm going to put that next to each other. Notice we have no more fractions. Now it becomes much easier to solve. I have to get rid of the parentheses, so what I'm going to do is distribute. We would normally use our boxes for this, our 2 by 2 boxes, but I'll go ahead and do that. If we did boxes, we'd have x squared plus 4x plus 3. And if you're not really sure, you just set up your 2 by 2 boxes and figure it out. I'll bring down my plus 18. Over here, if I distribute, 9 times x is 9x. 9 times 5 is positive 45. Because there's a power of 2, I want to get everything to one side, and specifically to the x squared side, but I'm going to combine like terms first. I can combine those. So we have x squared plus 4x. 3 plus 18 is positive 21, so plus 21. On the other side, I have equals 9x plus 45. I need to get all of this to the left-hand side, so I'm going to subtract 9x from both sides. I put it underneath the 4x. I'm going to subtract 45 from both sides. If I do that, my 9x's and my 45's cancel. So my new equation, I have x squared. 4 minus 9 is negative 5, so I have minus 5x. 21 minus 45 is minus 24 equals 0. Because there's a power of 2, I can factor, so I'm going to do 2 sets of parentheses. Don't forget equals 0. X and x go in the front. Factors of 24 that subtract to give us 5 would be 8 and 3. We want a negative 5, so we would have to do 3 minus 8. So 3 is positive, 8 is negative. Since we have two things being multiplied equal to 0, I can split these up now into their own equation. So we can have x minus 8 equals 0 and x plus 3 equals 0. And we're going to solve them both, but don't circle. So over here we see minus 8, so I'm going to add 8 to both sides. We get x equals 8. Over here, I'm going to subtract 3 from both sides. I get x equals negative 3. Before I circle my answers, I need to make sure that these are not going to make my denominator 0. So I'm going to go to the original problem. Here's my original. I'm going to plug in 8 to the bottom. 8 plus 5, 13. That's not 0, so I'm okay. If I plug in 8 here, 8 squared plus 8 times 8 plus 15, that does not give me 0. If I plug in an 8 here, 8 plus 3 is 11. So this answer is okay. If I plug in a negative 3, I'm going to skip right to here for a minute. If I plug in negative 3 here, negative 3 plus 3 is 0. I cannot have a 0 on the bottom, so this cannot possibly be our answer. So the only answer we have is 8. And you can always check this in your calculator. I will do a quick check just so you can see. Here's one way to do it. I'm going to go to y equals. And I'm going to type in the left side of my equation for y1. So I'm going to do alpha y equals. Oops, let me go up to the top. Alpha y equals. And I'm going to type in x plus 1 over x plus 5. Then plus, and type in this fraction. Alpha y equals 18 over x squared plus 8x plus 15. For y2, I'm going to type in the right side of my equation. So alpha y equals 9 over x plus 3. I'm going to look for my answers to see if it works. So I'm going to start with that negative 3 so you can see why it doesn't work. If I go to my table, if I go find negative 3, notice it says an error. That is because we had 0 on the bottom. So that proves we can't have that answer. I'll go down to 8. We have matching y answers. So that is the correct answer. One more example. This will be example C, and then we are done. This. So here's example C. We've got 3 fractions again. We've got a plus sign here. So our first fraction is 5 over x. Our second fraction is going to be plus x plus 1 over x minus 2. And our third fraction is x plus 4 over x squared minus 2x. So there's an equal sign right here. In order to solve this, we have to find the LCD and multiply by that. So we can't factor this, we'll leave it. We can't factor this. Over here, I can factor that. I can take out an x and I'm left with x minus 2. My LCD is going to be one of everything I see. So my LCD, I'm going to need an x. I'm going to need an x minus 2. And this already has an x and an x minus 2, so I don't repeat it. So this is my LCD. What am I going to do with that? I'm going to multiply all 3 fractions by the LCD. So I'm going to have us write this over again, but leave some space next to each. So we have 5 over x plus x plus 1 over x minus 2 equals x plus 4 over x squared minus 2x. So I'm having you rewrite it. And we're going to put that LCD over 1 next to every single fraction. So over here, I'm going to put x times x minus 2 over 1. Next to this, I'm going to put an x times an x minus 2 over 1. And over here, I'm going to put an x times an x minus 2 over 1. Every one gets that LCD. If we did it right, our denominators will cancel and we will be left with only the tops. So if you look over here, we have an x on the top and bottom, so that cancels. So we're left with a 5 and an x minus 2. So 5 times x minus 2. I like to put the x or the 5 in front. Now I go over here, my x minus 2's cancel, so I'm left with a plus, and we're left with x times x plus 1. So x times x plus 1 goes in parentheses. Over here, remember that this is the same as x times x minus 2. Notice you see x and x minus 2 on the top, so we get to get rid of them. So the only thing we're left with over here is x plus 4. Notice we have no more fractions. So we're going to distribute and we're going to get everything to one side like we did on the other question. So if I distribute, 5 times x is 5x, 5 times negative 2 is negative 10, x times x is x squared, so plus x squared, x times 1 is positive x, or positive 1x. On the other side, we're going to bring down the x plus 4. All right, what I want to do now, maybe I'm going to put it in order, makes it a little bit easier. So I'm going to put my x squared first. I can combine my x's, 5x and x is 6x, so plus 6x. And I have a minus 10. Over here, I have x plus 4. Because I have a power of 2, I want to get it equal to 0, so I'm going to bring all of this over here. So I'm going to subtract x from both sides. I put it underneath the 6x. And I'm going to subtract 4 from both sides, putting that under the 10. My x's and 4's cancel. My new equation, I have x squared. 6 minus x is positive 5x, so plus 5x. Negative 10 minus 4 is minus 14. And don't forget equals 0 at the end. Now that we have it equal to 0 and there's a power of 2, we can factor. So we're going to do 2 sets of parentheses. Don't forget equals 0 at the end. X and x in the front. Factors of 14 that subtract to give us 5 would be 7 and 2. We want positive 5, so that would be 7 minus 2. So 7's positive, 2's negative. Next part, I can split these up and set them equal to 0. So we have, I'll put it over here, x plus 7 equals 0, x minus 2 equals 0. Now we solve. Minus 7 on both sides. That gives us negative 7. I'm not going to circle yet. Over here, if I add 2, x equals 2. Now, before we circle any, we want to take a look at the original problem. Will either of these answers make the denominator, the bottom of the fraction, 0? Well, it would be this one right here, this 2. If you plug in 2 right here, 2 minus 2 is 0. We don't care about the top. Because that gives us a 0 on the bottom, we can't have that answer. Plugging in negative 7 on the bottom would work for all of them, so that would be our answer. And you can always check in your calculator to verify. Please make sure you submit these notes into Canvas to get credit for your work.